Ladies and gentlemen, welcome back to the 16th episode of Quant Chronicles. My name is Logan Legacy, and today on this episode, we are going to be breaking down the difference between multithreading versus parallelism. Whoops, I think I just ripped my page. Whoops, that's not good. Let me close this up. I'll look in this in a second. Okay, so on today's episode, we're going to be explaining essentially the CPU. And if you watched my last video that I posted last night, then you'll know that I took about 2 weeks off from posting on an everyday journey to post one video a day on YouTube, essentially landing, and we will land our first quant internship by the end of, by November 2026. Essentially. And in that 2 weeks, I needed to kind of take a little time off to essentially get my mind right because my brain was melting, if you watched my last video. And I just wanted to clarify that we are learning this in real time as you're going. So if you're learning how to become a quant developer, you are in the right place, my friend. So that is awesome, and we are going to be getting into multithreading in just a moment. I just wanted to clarify that we are learning this, ladies and gentlemen, in real time. What does that mean? That means I'm going to be right most of the time, but at the same time, I need some clarity and I need some senior developers to comment down below if I get something right. That is what I'm engaging with in the comment section. And if you want to talk to me on like a daily basis or whatever, you already know how to do that. So, and you know which Discord server I'm in if you've been watching very closely to my videos. But I'm not trying to spill too much alpha out there because, like I explained in my yesterday's video, there is essentially a lot of security concerns with explaining that stuff. And that's why I'm kind of picking and pulling and choosing exactly what to share because I definitely don't want to cross, Wall Street is funny on censoring. So yeah, we're essentially going to be trying to make everyone happy. But obviously, we can't make everyone happy. So that's just how it is. But I just wanted to clarify. Someone in my last video commented, and I thought this was super sweet. Someone said, I was really disheartened to know that he took 2 or 3 weeks off until he made this video explaining why he took 2 weeks off. And that is to soak in this information because, ladies and gentlemen, when you learn C++, when you're learning operating systems, the kernel, system architecture, all that fun stuff, computer science, you'll have one of these moments. If you haven't started programming yet, you're gonna probably get there at some point, and you're gonna be like, I need to take a little vacation, just kind of go on a little trip or something. So I just wanted to apologize for taking a little time off. I know some people were like, you're probably not, no one really noticed. But there was several people who noticed, and I just want to apologize for letting my fans down, letting you guys down. I'm here, and as I explained in the last video, we're going to be shifting this channel. I'm going to be trying to post one video a day. Like, I'm really trying to do that. But we're really going to be pacing, and next time I take like a week break, I'll definitely kind of like be like, hey, I'm about to take a week break instead of just disappearing and almost quitting. Because if you think that this is an easy journey to become a quant developer, yeah, it's really tough. Anyways, okay, so let's get into it today. Multithreading versus parallelism. What is multithreading? Let's start with this graphic below. To explain multithreading, I need to essentially explain the pipeline. So you can think of, let's do this first. So essentially, multithreading is essentially when the CPU works on multiple tasks by switching between them really fast. Think about it like juggling. Think about it like juggling. Like if someone throws something at the CPU and it's a new task, the CPU is just juggling if it's multi-threading, right? So let's look at the pipeline. Now, when you run a pipeline, like let's say you have a task, task one. Task one is gonna fetch the data, it's gonna decode the data, then it's gonna execute, then it's gonna write the data. Oh, can you still see me over here? So essentially this is task one, this nice arrowed line. It's gonna fetch, decode, execute, and write. And that's task one. Now, if we were gonna be multi-threading with a pipeline, essentially this is gonna be like putting task two right here, where traditionally, if we weren't pipelining, what would happen would be task one would run, fetch, decode, execute, write, and then, hopefully you can still see me over here, and then without the pipeline, essentially task two, if it wasn't pipelined, would start right here. And task two would go, oh cool, I'm done with task one, now I need to start task two. So task two, we would fetch, decode, execute, and write here. This is slow. This is slow. We don't want this. This is slow. I'm gonna actually erase this. This is slow. Task two is slow if we do it that way and we don't multi-thread. So now we're gonna pipeline this and we're gonna execute task two right after the fetch. So we're gonna do task one, it's gonna fetch, and as soon as we implement a pipeline, task two is going to start right here instead of like right here, right? So task two, if we didn't pipeline, would start here. And if we did pipeline, it would start right here. So you could understand probably why this would make sense to pipeline things, because we can essentially execute multiple tasks simultaneously. So if we do the pipeline's gonna fetch, decode, execute, and write. Boom, boom, boom. Perfect. Pipeline makes sense. Think about the pipeline as an assembly line. Like it's an assembly line. So that's awesome. Task two would start there, and I'm gonna actually just erase some of this stuff to make it easier to see. So yeah, think about it like an assembly line. Perfect. Now, and this is pretty cool, pretty interesting. When we are, and I'm actually gonna move this light over here. When we are, and guys, just to take a note and explain this, guys, I felt so bad about taking 2 weeks off that I busted out some of the some of the extra gear. So we're still recording everything on the iPhone, which once we get to like, I think my last goal was like something like 4,000 or 2,000 subscribers. We're gonna bust out the really nice camera. If you guys want to see the really nice camera with the really nice wide angle lens, it's gonna capture the notes, super detailed, be sure to share this video and comment and like and turn on that little bell notification right now so you never miss another episode of Quant Chronicles, so you're always in the know and so you know how to get a hold of me. Because Quant Chronicles, as of right now, we don't have a Discord, we don't have a Patreon, but if you've been watching closely, you know whose Discord I'm in. And in his words, like an orbit. I'm orbiting around a famous YouTuber. We all know, right? Do we know yet? Okay, well, if we don't, I'll just drop you a hint. It's Coding Jesus. We love Coding Jesus. Like, he's the GOAT. I'm in his Discord. Why am I in his Discord instead of starting my own Discord? Guys, because it's literally like the Hall of Fame for quant developers and just a great community. So shout out to CJ. So anyways, pipeline, multi-threading versus parallelism. Can I erase some of this stuff now? Yeah, let's do it. Let's erase the pipeline, the second task. Let's just erase this real quick. Make it nice and easy to read. Okay. So, and sorry, CJ, but erase that too. Okay, so now we're going to be talking about Parallelism. All right. Cool. Yeah, and yeah, essentially, I'll hit on this note real quick before we move to parallelism. Excuse me while my brain is a little bit everywhere tonight. Pipelining is essentially breaking one big task into steps and overlapping the steps. Super easy to understand. I'm going to erase this now. Okay, perfect. So, and so here we are. Parallelism. Parallelism is amazing. It requires two cores, but essentially markets, especially like Wall Street, crypto markets. Ooh, this light, I'm going to get this a little closer to me. We're essentially using parallelism most of the time. In markets need parallelism, and the reason is because they use multiple CPUs. So I have CPU 1, CPU 2, and essentially they're doing multiple works at the same time using two CPUs. The task actually runs simultaneously. The real speed boost happens here. All right, that's awesome. Parallelism is amazing. We need it. And this is pretty interesting. When you fetch something, there's a little C++ note down here. When you're fetching something, you're actually doing it on the hardware level. And just to make a note about C++ really quickly, so C++ uses all this stuff. And the real reason I really understood operating systems is because if you understand the operating system, then C++ doesn't feel as daunting because you're actually understanding the hardware and a lot of the same syntax. Well, it's a little different, but you can think about it like essentially there's a lot of overlapping stuff. And really, if I was going back to school for quant, let's just say like I went to Harvard or something like that, I would go and take computer science first, then I would take operating systems, then I would start to understand C++. Now that's going to be a big journey, and that doesn't have anything to do with like math or calculus or whatever, because you need a lot of that stuff too. But yeah, that's the way that I would learn it, because once you understand computer science, operating systems, kernels, and all that good stuff, memory management and all that stuff in the operating system, once you understand that, C++ just makes a lot more sense. And eventually, here pretty soon, once we do a few C++ projects on the channel, we will be breaking into Python and doing stuff like pandas. And that's where a lot of the data visualization and all the fun stuff really happens. And I don't know exactly when we're going to break into that, but essentially that is going to be where the real fun happens, because 9 times out of 10, you're going to be making quant projects, like to show a quant like to land a quant internship. You know, like you're probably going to make some of the stuff in C++, but C++ just talks to the hardware. You need like something that lives in a GUI somewhere, something that's like designed pretty well and uses a lot of math and calculus and all that stuff. And that's why, you probably want to use Python. But going back to what Coding Jesus is recommending, C++ is a must. And the real reason is, and I mean, I knew this before Coding Jesus said this, but the real reason is because C++ is essentially used on Wall Street, and the reason is because it's low latency and it's smoking fast. And parallelism, multi-threading, all that stuff is used in Wall Street quite a lot. So thanks for bearing with me. So essentially, you can think of multi-threading like one person that's going to be overloaded with tons of work, and that's why you hire a team of people. You hire a team of people so you can essentially go from essentially running, one task to the next task. You do multi-threading, so essentially you're like hiring a team of people. It's like not as much work essentially. So CPU uses the pipeline, and hyperthreading, and when you use the pipeline, when you use hyperthreading and you use the pipeline, you use multi-threading, you essentially go turbo speed. And hyperthreading is something that we will cover in a future video, maybe the next video. If you guys want to see that, I will cover hyperthreading. It's still clicking, is still making a little bit sense to me. Even some of this stuff is still, we just learned this stuff like literally like a week, maybe 2 weeks ago. So it's like, like a lot of this stuff is still pretty new. There's literally people who go to school, get degrees in just CPU multi-threading. It's like an iceberg. I'm just like super surface level. And if you really want to understand this stuff on like a way deeper level, then like by all means, there's a lot of really great videos. There's a lot of really good resources. Udemy has been amazing. I have the unlimited Udemy, which reminds me, someone commented on the last video and said, drop some of the Udemy courses. So I'll try to get a list of all those and put those out there and stuff like that. But we did like 8 or 6 or 7 Udemy courses like back to back to back within those 2 weeks that I was gone, and came back super strong and understanding stuff a lot better. And that's another reason why, is because when I was first starting the channel, I would like learn something and then I would explain it like later in the day, without really letting it soak in. And that's another reason why you really need to let this stuff soak in, and understanding, and ask way more questions than I'm even providing here today. So I'm pretty sure that covers everything. So multi-threading versus parallelism. Parallelism uses 2 CPUs. Multi-threading uses 1 CPU. Pretty much. Trading systems need multi-threading for sure. I'm trying to like see if I left anything out. Other than that, life is amazing. We are speed running. I'm on track to get this quant internship, and I'm really inspired by a lot of you guys too, because a lot of you guys are like, I'm learning this stuff too. And I mean, to me, that's super inspiring, because I thought, really, when I started this channel, I didn't even think anyone's would be watching it. I thought this was just gonna be like just me trying to like figure this stuff out on screen, and then a lot of people found this stuff interesting and have been following along. So thank you. I wrote here, the kernel is nothing but a big program. It's true. Stack heap, already discussed that in a previous video. Load fetch instructions actually work on the hardware level, which is freaking wild to me that there's like little bits and stuff. Just staying super curious with this stuff and really going deep when I need to. That is like the most important thing that you could do, is just like, if something seems interesting to you in this field of operating systems, kernel development, stack versus heap, whatever it is that you're learning, as you're learning it, dive deeper into those moments. And for me, this was multi-threading and CPU and understanding that. And so still a lot more reading, still a lot more stuff that I need to do. Thank you guys for bearing with me. And I'm pretty sure that's it. We're going to be trying to record. That's going to be a little challenging, but essentially we're going to be trying to record some of the computer, some stuff while I'm coding. And so still trying to get that figured out. I mean, I could screen grab it. It's not a big deal, but just the way that I'm recording this, because I like this fluidness. I like feeling like a professor up here. Maybe one day I'll be a professor. teaching computer science or maybe teaching quant development, who knows? But that is the role. That's why I'm here. That's why I have the whiteboard. Also, this is probably a new scene. I'm at my office, and none of these books are my books. It's just a shared office space, and this stuff all belongs. So if you're like reading some of these books or thinking that I'm like the most, I mean, I do have a big book collection, but they're all at my house and not at my office. And all these books are, you know, just from the office and stuff. So that's awesome. Guys, I think that's it. I'm not really thinking of too much of anything else. I mean, I guess I could go through some of these notes. I have a lot of notes. But yeah, I mean, C++ is amazing. Learn it. If you don't know about C++, what are you doing? If you're trying to do quant development, I mean, Python's good, but C++ is just the way to go. Yeah, operating system scheduling, CPU, memory, I/O. Yeah, that's pretty much it. And just understanding like system architecture, understanding the syntax is good. I feel like it's a little bit, it's not necessarily overwhelming, but trying to be like, you know, just understanding each little word in the syntax, like it's good, but also like I feel like it's better for me at least to understand the larger picture. And that's why understanding some of these general topics are going to help you. It definitely helped me to learn C++ a lot better. So anyways, thank you guys so much, and I will see you tomorrow. Peace.